Okay, now we're going to work on section 7.4 with the concept of multiplying radicals. There's a few rules we're going to use over here on this right hand side. I'm going to write some more rules. I want to start by going back and saying, hey, what would we do if we wanted to multiply 3 times x minus 5? Well, here we would distribute. We would say this is 3x minus 15. Okay, so we could use the distributive property. And it basically says, if you can't add these together, which x and 5 aren't like terms, so we can't, then let's just multiply them together and get what we can. So what would this look like in radical form? This would look like something like, the square root of 7 multiplied by the square root of 5 plus the square root of 3. Well, these are not like radicals, like we just discussed. They don't have the same they don't have the same radicand or the same index, and the same index, so then I'm just going to distribute. Remember, when we multiply two radicals together, if they have different bases here, I can put the bases together underneath. So I could say, well, 7 times 5 is the square root of 35. Okay, and then when I multiply here, I would get plus the square root. 7 times 3 is 21. Neither one of these simplify because all they factor back down to is this 5 and 7 and a 7 and 3. Now, these aren't perfect squares, so this is as good as this gets. I can't combine these. They're not like terms, like radicals. They're just, I can just distribute. So all I can do here is distribute. There's no simplifying for this one. Let's do a couple more of these where we distribute and see what that looks like. Well, what if I had the square root of 3x and I wanted to multiply that by the square root of 3 minus the square root of x? Well, again, when I multiply these together, I multiply what's underneath the radicals together. So I would multiply 3 times 3 is 9, and I would get the square root of 9x. Here, I would get the square root minus the square root of 3x squared. 3 times x is 3x squared. 3 times 9 is 9x. So now looking at these, I can simplify this 9 because the square root of 9 is just 3. And the square root of x squared is just x. So I have to simplify them, but in this case it doesn't help me combine them, but you should always write them in the most simplified form. Okay, well, what if I have something on the inside and the outside when I'm trying to distribute? So say like I had 3 root 5 times 6 minus, 2 root 5. Well, if I'm going to multiply these together, what am I actually multiplying together? Well, 6 is 6 and 3 is 3. So 3 times 6, they're both on the outside, or they're both whole numbers. So I'm just going to literally multiply them together. So 3 times 6 is going to give me 18. But I'm still multiplying by the square root of 5. So the first terms here multiplied together are going to give me 18 square roots of 5. When I go to these terms, though, I've got this 3 and this negative 2 on the outside. That is going to give me a negative 6 on the outside. The square root of 5 times the square root of 5 is the square root of 25. But I want you to recognize something here, that the square root of anything times that same square root is just going to give you that thing. So in other words, the square root of 5 times the square root of 5 is just 5. Okay, so this 25 right here, the square root of 25 can be simplified, so we get 18 square roots of 5 minus 6. Well, the square root of 25 is just 5, and the relationship here, again, is this multiplication. So we would have 18 square roots of 5 minus 30. This is the simplified answer if you had coefficients on the outside. So whatever's on the inside or underneath the radical stays under the radical, unless it's a perfect square and it can come out. Whatever's on the outside stays on the outside when you're multiplying these together. So this is distributing. But what if we have two terms that we want to multiply together? Well, instead of distributing, we're going to FOIL. Remember that FOIL means firsts, which is the first one in the first term in the first set of parentheses, times the first term in the second set of parentheses. Outers, which is the outside of each of the two, they're ones on the outside. Inners. So this method is just to help us keep track of what multiplication we've actually done. Okay, and then we have lasts, which this is the last term in the first parenthesis, and this is the last term in the second parenthesis. So those are the locations. If you're looking at this in actual terms, if I had, say, x minus 5 times 7x plus 2, what I'm literally doing is I'm just saying, well, I have to multiply this x by this thing and by that. So by both of these terms, the x has to be multiplied. Well, this is the firsts, and this is the outers. But then I also have to multiply this negative 5 by both of these. So this is the inners and the lasts. So just like when I do this, I'm going to say, you know, x times 7x is going to give me a 7x squared. And then when I do the outers, I'm going to get plus a 2x. When I do these inners, I'm going to get a minus 35x and a minus 10. These are like terms, just like we have like radicals, we can have like terms. So these can combine, and this would be a negative 33x minus 10. So why am I showing you this when we're supposed to be talking about radicals? Because the process is the same. We FOIL when we have two terms times two terms. Okay, so that's the same whether I have a polynomial or I have radicals. So if I had the radical, say the square root of 6 minus the square root of 2 times the square root of 2 plus the square root of 5. Okay, something like this. Then what I would do here is I would FOIL. I'm going to do the first times the first. Again, both of these are underneath, so 6 times 2 is going to be the square root of 12. Then I'm going to do the outers. 6 times 5 is 30, and they're both underneath, so I'm going to say the square root of 30. The inners, I'm going to get a negative. The square root of 2 times the square root of 2 is the square root of 4. But remember, the square root of 4 is just 2. Okay, any radical times itself is going to give you just the radicand. Then I'm going to have this negative square root of 2 times this positive square root of 5. That's going to give me a negative square root 10. Now, I need to look through each one of these and see if I can simplify them. This only has factors of 2 and 15 and, let's see, 3 and 10 and 5 and 6. None of those are going to simplify. So this square root of 30 is as simplified as I can get. Can't simplify this any further, and this is only 1 and 10 and 2 and 5, so I can't do anything with that either. But here I can break this down to 3 and 4. So I need to pull out the 2 because 4 is a perfect square. So I would have 2 root 3 plus the square root of 30 minus the square root of 10 minus 2. The order of these don't matter as long as you keep the sign in front of it with it. So this would be our final answer here when we FOIL. Let's see if we can do one that's not a squared root, but instead a cubed root. So what if we had the cubed root of a plus 2 times the cubed root of a plus 7? Well, the cubed root of a times the cubed root of a, just the radicands are going to stay underneath, so I'm going to have the cubed root of a squared. Okay, so that was the firsts. The outers, I'm going to have just 7 times the cubed root of a. The inners, I'm going to get 2 times the cubed root of a. Okay, and the last 2 times 7 is going to give me 14. Well, just like when we FOILed that polynomial, we can combine like terms. This can't be simplified any further, but these are like terms. They have the same radicand and the same index, so I can combine them. So the final answer here would be the cubed root of a squared plus 9 cubed roots of a plus 14. So this would be our final answer here. We want to look at a few more situations and where we have special products. Let's try the cubed root of 4 plus 2 times the cubed root of 2 minus 1. Again, I have 2 terms because they're separated by addition and subtraction. 2 terms separated by addition and subtraction. So I'm going to FOIL these. The first times the first is the cubed root of 4 times the cubed root of 2. 4 times 2 is 8, so we have the cubed root of 8. Well, the cubed root of 8 is just 2. Then I'm going to do negative 1 times the cubed root of 4. That's going to give me a negative cubed root of 4. Again, the 1 is assumed here, so it's like there's a 1 here. You can think of it that way. But we just write it the cubed root of 4 because 1 times anything is itself. Then I'm going to multiply here and get 2 cubed roots of 2. Then I'm going to multiply the lasts and get negative 2. So if I look at this, these are not like terms. They can't be combined. This is not a perfect cube. I can't do anything with it. So I'm going to subtract or have a negative 3 cubed root 4 plus 2 cubed root 2 minus 2. Well, I can combine this constant with this constant, but 2 minus 2 is 0. So what we will end up having here then is just the negative cubed root of 4 plus 2 cubed roots of 2 when we FOIL these. All right, so hang in there. We're going to do a few more. Now we're going to talk about special products, which we have done before. I'm going to go over, hopefully by now we've kind of drilled in and beaten with a dead, beat until you have a dead horse or whatever that saying is. If we have x minus 2 and I want to square this, this means that I have 2 of these terms being multiplied together. This squared right here means that I've got 2 of those. So the way that I would do this is I would multiply the first outers and inners and lasts. I'm going to do this just real quick here. X squared minus a 2x minus a 2x plus 4. And what we get here when we combine these like terms is a perfect square trinomial. So we've heard all these before. So this is a binomial squared. So what do we do if instead of this being a polynomial, we have a radical expression with 2 terms? Well, it's going to do the same thing. Because if I have the square root of 3 plus x, and I want to square that, this literally means that I have everything inside of this parenthesis twice. And it's related through multiplication. So if I'm going to FOIL this, I'm going to get the square root of 3 times the square root of 3. Remember that anything times itself, that's just going to give me the square root of 9. But the square root of 9 is the number 3. So that's our firsts right here. Then I'm going to do my outers. That's going to be plus x square root of 3. I'm going to do my inners. That's going to be a plus x square root of 3. Then I'm going to do my lasts. X times x is just going to give me an x squared. These are like terms. This is just one of these though. So this is like I have 1 here and 1 here. So when I combine them, it's not going to be x squared cubed square root of 3. It's going to be 2x. Because I have 2 of these terms. 2x root 3 plus x squared. So this would be expanding a 2-term radical. Remember, I can't just like say that that's 9 and x squared because I'd be missing this middle term right here. I've got to expand it and FOIL. Follow through with the FOIL. Okay, this is true if I have a plus here or if I have a minus here. That doesn't change anything. So if I had a minus, then might look something like this. The square root of y minus 3x. And I want to square this. Well, again, this just means that I have these terms twice. Hopefully this repetition is good, and seeing all the different possibilities is helpful too. So remember, the square root of y times the square root of y is the square root of y squared. But y squared, the square root of y squared is just y. Okay, going back to using this rule right here. That's the firsts. When I do the outers, I'm going to get a minus 3x square roots of y. Inner is going to give me the same thing, minus 3x square roots of y. And the lasts, 3 times 3 is going to give me a positive 9, and x times x is going to give me an x squared. But again, I can combine these because they're like terms. So I'm going to get y minus, is this going to be 9? Is this going to be x squared? What is this going to be? Well, I have a negative 3 and a negative 3. I'm going to combine those to a negative 6. But this is still x, and this is still the square root of y. So all we're combining is these coefficients here, plus 9x squared. Okay, so here is what we would get when this is a minus. You'll notice you'll get this middle term. Again, you can't just like dump this squared into here and get y plus this 9x squared, because you'd be missing this middle term, just like you would. This is a perfect square trinomial, or similar to the same pattern as the perfect square trinomial. Okay, well, what if, let's talk about the concept of a conjugate. This is our last piece of this section of multiplying radicals. So what is a conjugate? Well, you know, back when we were factoring and we were talking about, well, what if I have x plus 3 and an x minus 3, and I multiply these by FOILing, and I get this x squared minus a 3x plus a 3x minus 9. And remember that these here sum to 0. So I end up getting this difference of two squares. This is a perfect square and this is a perfect square. Well, these are conjugates of each other. Conjugates means the same two terms but with opposite signs. Okay, so if I asked, what is the conjugate of 3x minus 2? The conjugate would be the same two terms but with a plus. Well, what if I said, well, what's the conjugate of the square root of 5 plus 1? Well, you'd say, well, it's the square root of 5, but change the sign to minus 1. So these are conjugates. Yeah, this is true if I have any radicals in there. So if I had the square root of 2x minus the square root of, 7y, the conjugate of this would be the square root of 2x plus the square root of 7y. So we've talked about conjugates before, but why do we care about conjugates? Well, what happens here when we multiply conjugates together? So if we just said, hey, well, let's multiply this conjugate, but it's a radical conjugate, I do the first times the first. Well, the square root of 2 times the square root of 2 is the square root of 4. But remember, the square root of 4 is just 2. When I multiply this outer, I get a negative on the outside. Negative 1 times a negative times a 1 is a negative. And then I get the square root of 10. On the inside here, I will get square root of 10 when I do the inner times the inner. And on the last, I get the square root of 5 times the square root of 5. It's going to be a minus. But 5 times 5 is the square root of 25. But remember, the square root of 25 is just 5. And if you look at these, They will always sum to 0. If I have negative one of these and I add one of these, well, they don't exist anymore. So literally when I multiply these conjugates of radicals together, I get like 2 minus 5, which ends up being just like negative 3. So when you FOIL conjugates, you end up with something funky, just like a number. This is really important going into our next section, 7.5. So we'll talk more about this in 7.5.